All right, let's start covering the homework for Chapter 7.2. The first question that we're being asked is we are to find the exact value for the cosine of 7 pi over 12. If I were to look at this diagram right here, there is no angle, no radian, that equals 7 pi over 12. I got 7 pi over 4, I got 7 pi over 6, but I don't have 7 pi over 12. So I need to come up with two radian angles that we do have here that when added together will equal 7 pi over 12. And then I can use the cosine formula for finding sums of angles in order to find an exact answer. So let's go ahead and do that. Let's see. So pi over 12 plus 6 pi over 12. Well, this will reduce to pi over 2, but this won't reduce at all. So let's move to 2 pi over 12 and 5 pi over 12. Why am I doing this? Because 2 pi plus 5 pi is equal to 7 pi over 12. This doesn't reduce, so that's not a good one to use. 3 pi over 12 plus 4 pi over 12. Well, these do reduce. This is pi over 4, and this is pi over 3. And those we can use. So I'm going to rewrite over here the cosine of pi over 4 plus the cosine of plus pi over 3. And I'm going to use those instead. I can erase this and work with this formula here. There's a cosine formula that states that if I add two angles together, and I'm going to take its cosine, it's going to be cosine of alpha a. So we need to write a few things down. So cosine of alpha, well, what is that? Well, that's the cosine of pi over 4. Well, what is the cosine of pi over 4? Well, that is the square root of 2 over 2. We also need the cosine of pi over 3, which is my beta. Well, the cosine of pi over 3 is 1/2. I also need the sine of alpha, the sine of pi over 4. This is my alpha, and this is my beta. So the sine of pi over 4 is the square root of 2 over 2. And the sine of beta is the sine of pi over 3, which is the square root of 3 over 2. And then I use the cosine sum of angles formula. It's cosine of alpha, which is going to be the square root of 2 over 2, times the cosine of beta, which is 1/2. And that's going to be minus the sine of alpha, which is the square root of 2 over 2, times the sine of beta, which is the square root of 3 over 2. Simplify this. I get the square root of 2 over 4 minus the square root of 6 over 4. And I can rewrite this as the square root of 2 minus the square root of 6. All of that is divided by 4. Okay. That is my answer to that, and that is the exact answer to the cosine of 7 pi over 12. So I can come up here and I can rewrite this as square root of 2 minus the square root of 6 over 4. That is the exact answer. Do the same thing here, the sine of pi over 12. Again, there is no radian angle on my circle that has 5 pi over 12, so I'm going to need to split this up. So if we were to use, let's go 3 pi over 12 plus 2 pi over 12. This is going to be pi over 4 plus pi over 6. And I do have answers for both of those, so I'm going to go ahead and use that. That's going to be the sine of pi over 4 plus pi over 6. I'm going to go ahead and erase this so I have some room. All right, so I need to write down a few pieces of information. I need to know the sine of alpha, which is the sine of 1/4, or pi over 4, which is the square root of 2 over 2. I also need the sine of my beta angle, which is pi over 6. Well, the sine of pi over 6 is 1/2. I also need the cosine of my alpha angle, which is the square root of 2 over 2. And I need the cosine of my beta angle, which is the square root of 3 over 2. This is my alpha angle, and this is my beta angle. Then I use the sine addition formula, and that's going to be sine of alpha square root of 2 over 2 times the cosine of beta, square root of 3 over 2. That's going to be plus the cosine of alpha, square root of 2 over 2, times the sine of beta, 1/2. And multiply those together, square root of 6 over 4, plus square root of 2 over 4, and I have my exact answer. The square root of 6 plus the square root of 2 divided by 4. Okay, let's move on to the next one. Tan of minus pi over 12. All right, well, let's see. If I did 4 pi over 12, excuse me, and if I subtracted that from 3 pi over 12, I would get negative pi over 12. So that would be pi over 4 minus pi over 30. And that should be what I can use. So pi over 4 minus pi over 3. And I will use a difference of these angles and the tan formula for that. So let's go ahead and erase this. Give me some room. And let's rewrite a couple of things. So I need to know the tan of my alpha angle, which is the tan of pi over 4, which is the square root of 2 over 2 divided by the square root of 2 over 2, which is 1. I need to know the tan of my beta angle. Well, that's pi over 3. So that's going to be the square root of 3 over 2 divided by 1/2. And that is equal to the square root of 3. So I have my alpha, I have my beta. It's time to use the tangent formula. This is subtraction. So tan A, which is 1, minus tan B, which is the square root of 3, is going to be divided by 1 plus tan A, which is 1, times tan B, which is the square root of 3. And if I were to rewrite this, then I can basically rewrite this as my answer. It's the minus 1, or 1 minus the square root of 3, over 1 plus the square root of 3. And that is the answer to that problem. We are asked to simplify this. Let me just make sure that I have this correctly. For the following exercises, rewrite in terms of sine x and cosine x, okay? So let's go ahead and do that. So we are to use the sum property of sine, summing two angles together. So we again will write out my values. Sine of my alpha, this is my beta. So sine of alpha is x. I don't know what it is. It's a variable, so I can't really put anything down for that. But the sine of beta is 11 pi over 6, and that actually does have a value. The sine of that is going to be negative 1/2. Now the cosine of alpha is x. I don't know what that is. But the cosine of beta, which is 11 pi over 6, is the square root of 3 over 2. And if I use the sine formula, that's going to be, and I'll rewrite it here, it's the sine of A times the cosine of B, and it's going to be plus the cosine of A times the sine of beta. So sine A was x, cosine of beta was negative 1/2. Actually, that should be sine x. I need to rewrite that. Sine of q, sine of x, the sine of an angle. We don't know what that angle is. It's not x. It's actually going to be sine x. So I should rewrite that as sine x. Same thing here. I should rewrite that as cosine x. So sine x times 1/2 plus cosine A is cosine x. Again, A is my angle, but x is my angle, so that doesn't really change anything. So it's just cosine x times cosine of B, my beta, or sine of my beta angle, which is 11 pi over 6. That's one. I'm sorry, this right here is cosine beta. So that's supposed to be square root of 3 over 2. And this is negative 1/2. So I rewrite this as the square root of 3 over 2 sine x plus, actually minus, so I can erase this, minus 1/2 cosine x. And that's really all they want you to do, is to just rewrite it in terms of sine and cosine. And we have done that. Okay, let's do the next one. This is cosine. We're subtracting angle x from angle 5 pi over 6. So we write down a few things. We write down that cosine of alpha is just going to be equal to the cosine of x. The cosine of beta is 5 pi over 6. Well, whatever 5 pi over 6 is going to be negative square root of 3 over 2. The sine of alpha is just sine of x, and the sine of beta is the sine of 5 pi over 6. That's 1/2. It's a cosine difference of angles, so we're going to write that out as cosine alpha times cosine beta plus sine alpha sine beta. So cosine alpha is cosine x times cosine beta, which is the negative square root of 3 over 2. Sine of alpha is just sine x, and sine of beta is 1/2. So I can rewrite this as the follows: 1/2 sine x minus the square root of 3 over 2 cosine x. That's the answer to that one in terms of sine and cosine. Okay, now we have switched to a new set of problems. For the following exercises, we are going to simplify the given expression, and these do look like they're cofunctions. So what does that mean? Well, remember what a cofunction is. A cofunction is, for example, if I have sine of a angle theta, I can rewrite that as cosine of pi over 2 minus that angle theta. We've proven that with the lecture. But I got cosecant. Well, I'm going to need to write this in terms of sine and cosine if I'm going to get anywhere. So let's go ahead and rewrite this as 1 over sine pi over 2 minus t. Well, we recognize this as a cofunction of cosine, so I can rewrite this as 1 over cosine t. And I can rewrite this as secant t. So the cofunction of cosecant is in fact secant t. Pretty cool. Let's do the same thing here, cotangent. Well, the cofunction of cotangent of here, we're not quite too sure what that is, but we could rewrite this as cosine of pi over 2 minus x divided by sine, because this is in fact what cotangent is. Well, the cofunction of this is sine x, and the cofunction of this is cosine x, which this, as we can see, is equal to tan x. So tan x cofunction is equal to this. Again, pretty cool. All right, now we have, given that sine A, sine alpha, is 2/3, cosine beta is negative 1/4, with A and B both in the interval. So we don't know what that angle A is, but it's in the interval of pi over 2 pi, and it is in the interval for cosine is in the same interval. We're going to find sine of A plus B, and we're going to find the cosine of A minus B. Okay. So, a couple of things. The sine of A plus B can be rewritten in the following way. It's the sine of alpha, or the sine of A, times the cosine of B, plus cosine of A times the sine of B, or beta. Well, I have already discovered that sine A is 2/3, and cosine B is 1/4. But I don't know what cosine A is, and I don't know what sine B is. But I can get them. I can use a Pythagorean identity to get them. So let's go ahead and do that. Since I know that sine squared A plus cosine squared B is equal to 1. Then I know that 2/3 squared plus cosine squared B is equal to 1. Then I know that cosine squared B is equal to 1 minus 4/3, or 4/9, I mean. That's going to be equal to 5/9. And so that's going to be the square root of 5/3. Is that between pi/2 and pi? Well, pi/2, we need to put that into I guess we suppose we can put that into a calculator as long as it is, well, these are the intervals, these are the angles. So actually, I'm not too worried about the angles themselves. We're just assuming that they're both within that interval. I've actually found cosine B. So cosine B, which wait a minute. I may have inadvertently, no, this cosine A. I don't know why I wrote B. That was dumb of me. That's cosine A. Cosine A, okay. Yeah, that didn't make any sense. So cosine A is the square root of 5/3. I need to find sine B, so I need to do the exact same thing. Sine squared beta, and I'm just going to write it quickly, minus cosine beta, which is negative 1/4 squared, which is just 1/16 positive. That's going to be equal to 15/16. So that's going to be equal to the square root of 15/4. So this is the square root of 15/4. Multiply these together. That is going to be negative 2/12. And that's going to be the square root of 5 times the square root of 15, which is just the square root of 75/12. And so that's equal to 2 plus the square root of 75/12. Here's the neat thing about all of this is that this information that I found, I might be able to use it in addition to finding cosine A minus B, because the solution to cosine A minus B is equal to cosine alpha, cosine beta, plus sine alpha, sine beta. We've already discovered what cosine alpha is. I've discovered it here. It is square root of 5/3. And cosine of beta was already given to me up here. Cosine of beta was negative 1/4, so we're going to write that down, times negative 1/4. The sine of alpha was already given to us up here, so that is 2/3. And the sine of beta was already found up here, or I'm sorry, down here, to be the square root of 15/4. And so then now I multiply these together. That's the negative square root of 5/12 plus 2 times the square root of 15/12. And we can rewrite this as 2 times the square root of 15 minus the square root of 5/12. Beautiful. So those are the two answers for that one. Cosine A minus B is 2 times the square root of 15 minus 5 divided by 12. And the answer to sine A plus B is negative 2 plus the square root of 75 divided by 12. All right. We need to find the exact value of each expression. And these are inverse functions. Okay, so what angle cosine gives me the value of 0? That's pi/2. So this could be rewritten as sine of pi/2. What angle of cosine is going to give me 1/2? And that is 60. That is pi/3. So this angle is pi/3. And it's as simple as solving for this difference, which is the sine of alpha cosine beta minus cosine alpha sine beta. And we need to find all of that information. So sine of alpha, which is pi over 2, that is in fact 1. And the cosine of beta, which is pi over 3, is going to be 1/2. That's minus the cosine of pi over 2, which is 0, and the sine of pi over 3, which is the square root of 3 over 2. But that doesn't make any difference because this is going to be 0 anyway. So this gives me an answer of 1/2. Okay, so that's the answer there. That wasn't too bad. Let's do it again. What angle of sine is going to give me the answer 1/2? And that's 30 degrees or pi over 6. What angle of cosine is going to give me 1/2 as the answer? And we discovered that's pi over 3. And I'm taking the tan of this difference. So the formula for this one is tan alpha plus tan beta. Sorry, it's a difference, so it's minus tan beta. And that's divided by 1 plus tan alpha tan beta. All right, tan alpha, well, whatever the tan of pi over 6 is, well, that is, let's just write that down. Tan alpha, let's rewrite that better. The tan of alpha is 1/2 divided by the square root of 3 over 2. Well, that's just 1 over the square root of 3. Tan beta is 1/3. That's the square root of 3 over 2 over 1/2. And that's just the square root of 3. All right, well, this is going to be interesting. So 1 over the square root of 3 minus the square root of 3. And that's over 1 times the square root of 3 times the square root of 3. Well, these two cancel. And I suppose I can multiply this by the square root of 3 top to bottom, so I can say that this is multiplied by the square root of 3 over 3. I'm just multiplying this value by 1, so why not? And I'm going to get 1 over the square root of 3 is subtracted by square root of 3 times the square root of 3, which is going to just give me 3 square root of 3. And this is over 2. And so this is going to give me 1 minus 3 over the square root of 3 over 2. I can multiply this by just 1/2 because that's what that is basically telling me. And I now have, well, 1 minus 3 is just minus 2. Minus 2 times 1 is just minus 2 divided by 2 times the square root of 3. And that should be the answer to that question. And if you plug those in, we should get minus 2 times divided by 2 times the square root of 3. We can check this. We can go ahead and check this. I mean, I'm hoping that this is right. This seems pretty solid, and maybe that's exactly what I'm going to do because I seem a little hesitant about that answer. But let's see what we've got. So the tan of pi over 6 minus pi over 3. So we just need to add those two things together. Let's do that by hand, actually. So pi over 6 needs to be 18, so that needs to be 3 pi over 18. And that needs to be 6 pi over 18. So that's going to be negative 3 pi over 18. That's going to be 3 and 18 is 6. That's negative pi over 6. Seems a little interesting to me. But that's exactly what it is. It's just negative pi over 6. So whatever tan of negative pi over 6, well, we can get that actually. We can get the exact answer to that one because negative pi over 6 is just 11 pi over 6. And that answer is negative 1/2. Just write this down here. I'll write this in red, actually. That answer is negative 1/2. Let's extend this page a little bit. Divided by the square root of 3 over 2. And that's just 1 That's just a negative 1 over the square root of 3. Well, wait a minute. Look at this. These 2's cancel. And that's 1 over the square root of 3. Okay. Close, but yet we are correct. Those 2's do cancel. I do get negative 1 divided by the square root of 3. And we have proven that that is, in fact, the correct answer. All right. For the following exercises, simplify the expression, then graph both expressions as functions to verify the graphs are identical. Oh, we got to do some graphing. This isn't going to be fun. Well, I mean, it'll be fine, but it's going to probably take just a little bit of time. So let's go ahead and let's draw a graph. Let's do that. We need to simplify the expression, and then we're going to graph both expressions as functions to verify the graphs are identical. Well, if we simplify this, sine x minus, or sine pi minus x, well, we need to do the following. What is sine alpha? Well, that's just sine of pi. Well, what is sine of pi? Sine of pi is 0. What is sine of beta? Well, that's just sine of x. What is cosine of alpha? Cosine of alpha is pi. That's negative 1. And what is the cosine of beta? Well, that's just the cosine of x. And we are subtracting two angles, so sine alpha minus beta. So that's the sine of alpha, which is 0, times the cosine of beta, which is cosine x. And that's going to be minus the cosine of alpha, which is negative 1, times the sine of beta, which is sine over x, which is sine x. This cancels because 0 times anything is minus 1 times sine x is just going to be sine x. So this is equal to sine x. And we need to graph both of these. Well, how can we graph this? Well, let's do this. 1, 2, 3, 4, that'll be pi. And each one of these is pi over 4. 1, 2, 3, 4, that'll be 2 pi. What is sine x? Well, that's actually not that hard. We graphed this before. We start here. I'm going to graph this with red. We start here. We come up to here at the halfway point. And we're going to come back down to pi. Come back down to negative 1 at this halfway point, and back up to 2 pi. Now, I don't know if I'm going to be able to draw this or not, but let's see. Not very good. Okay, so then what is the sine of pi minus x? Well, let's plug in some values for x. Let's say that x is 0 right here. Well, what is that? Well, that's going to be sine of pi. Well, what is sine of pi? Well, 0. Okay, so we're already here, so I'm going to plug this in with blue. So let's just write this down so that you see this. Sine of, if x is 0, that's going to be sine of minus pi minus 0. That's going to be equal to sine of pi. And the sine of pi, as we all discovered, the sine of pi is 0. Okay, let's shrink this thickness down a little bit. All right, now, let's put a couple of other things in here. What is the halfway point here? So pi over 2. What is the sine of pi over 2? Well, that's going to be, if x is pi over 2, well, that's pi minus pi over 2. Well, that's just sine of pi over 2. Well, we've discovered that that's already up here. What is the sine of, if x is pi? Well, that's sine of 0. Sine of 0, as we discovered, is 0, so we are here. The sine of 3 pi over 2, that's just going to be pi minus 3 pi over 2. That's negative pi over 2. Well, negative pi over 2 sine, negative pi over 2 is just angle 270. That's just 3 pi over 2. We can use the angle for 3 pi over 2. That's fine. That sine is going to be negative 1. We're down here. I'm just plugging in values for x and getting values for y. If x is 0, if x is pi over 2, and why do I care about these values? Because these are my values of x that I graphed sine with. So what is x 0 over here? What is x pi over 2 when I plug it in over here? What is x if it's equal to pi when I plug it in over here? We're going to notice that they're all the same values. And so this graph, sine x, does equal the same graph as sine of pi minus x. And I just proved it by just plugging in values for x that we've already graphed on my sine x graph. No problem. Let's try another one. This is tan, so we're going to need to draw a graph again. But this time we can draw the graph just a little bit more even, since our periods are going to be more along the line of a little even here. So we know that, still in blue, I don't know why it's in blue. We know that the periods for tan is pi over 2 and negative pi over 2. We know that those periods exist. So we definitely want this to be in there as anchor points so that I can get a center point. And we have these points, 1, and since it's not amplified or compressed, those should help us out. So we graph, well, we simplify this first. So we need to do a couple of things. Let me erase this. Couple of things. Number one, what is the formula that is being shown here? Well, that formula is the following. Tan of alpha plus the tan of beta is divided by 1 minus tan of alpha, tan of beta. All right, well, what's tan of alpha? Pi over 3. So what's tan of pi over 3? Well, that's just the square root of 3 over 2 over 1/2. That's the square root of 3. So tan of alpha is the square root of 3. What is the tan of beta? Well, that's just x. I don't know what that is, so I'm just going to have to write tan x. And this is going to have to be times tan x. And there really doesn't seem to be any way of simplifying that any further. I mean, I could use maybe some fraction rules, but this is a pretty tough graph to deal with. So we need to graph this and see whether or not it's the same as this. Here's the thing. It's easier, I think, in my mind, to start with this graph because I'm going to do the following. If x is 0, I'm right here. What is then, therefore, tan of pi over 3? That is the square root of 3 over 2 over 1/2, which is the square root of 3. Well, what is the square root of 3? We could plug that into a calculator. Take the square root of that. That's 1.73. So I'm going to go ahead and put in a couple more plugs in here. And that said 1.73, right? Well, then that's going to be roughly right about here. If I plug in pi over 4, well, we need to pi over 4 plus pi over 3. The problem with this is that I really can't get this exact answer through this particular graph. I need to actually use this formula yet again. So the tan of pi over 4 we know is 1, plus the tan of b, pi over 3, which is the square root of 3, and that's going to be 1 minus, that's just going to be 1 minus the square root of 3. Now, unfortunately, yeah, we are going to have to plug that into a calculator. So let's go ahead and do that. So 1 plus 3 square root, and that's going to be 2.732. We're going to write that down. We're going to divide that by 1 minus the square root of 3. So 1 minus 3 square root, and that's going to be negative 0.732. And then let's divide both of those. 2.732. It's going to be negative, so I'm just going to divide it by 0.732. And I get negative 3.73. So this here is negative 3.73. So we're going to be up here. Well, actually, let me erase that because this is 4. 3.73 is roughly there. And here's the fun thing. I could get the mirror anchor point here. I could probably do that by trying to figure out just how far I've gone up. And I suppose I can, guesstimate that I've gone up 2, which means I can go down. So I would go to here, and I would go to here, and I could guesstimate that this would be where my graph is. And then now I know that since this is my asymptotes, that I'm going to do the best that I can to graph this. And that's what this graph here looks like. Is that what this graph is going to be? Well, I only need to check 3 points. What 3 points are those? When x is 0, when x is pi over 2, and that's it. Actually, I need to check 2 points because if I find out that these 2 points are the same, I could try to assume that this point is the same. So let's plug in tan of 0. Well, tan of angle 0 is 0 over 1. That's just 0. So this is going to be equal to, let me just, if x is 0, then this is the square root of 3 plus 0 over 1, and this is going to be 0 here, so that's just going to be over 1. This is just going to be equal to the square root of 3. And I do believe that that's exactly what we got here. If x was 0, the tan of pi over 3 was the square root of 3 over 2 divided by 1/2. That's the square root of 3. So far, so good. We have discovered that this point is, in fact, the same point. Let's do the same thing with x is pi over 4. So that's going to be tan of pi over 4. Well, tan of pi over 4 is just 1. So that's going to be equal to, so when x is 0, or x is 1, that's going to be equal to the square root of 3 plus 1. And that's going to be over 1 minus the square root of 3. Well, that is exactly the same as this right here. Okay, that's exactly the same. So that point matches. And I do believe that I could imply that that point is most certainly going to match if I plug in negative pi over 4. And so, therefore, we do have the same graph. Notice what I had to do to prove to myself that this was in fact true. And look at all of the things that I had to write down. Look at all of the inferences that I had to make here. So when x is 0, this matches this. When x is 1, this matches this. They are the same. And so I can, therefore, definitely infer that these two graphs are the same. All right. Cosine graph. All right, last graph, I believe. So let's go ahead and draw a graph of this. Same idea. Let's draw these in fourths. 1, 2, 3, 4. That's pi. 1, 2, 3, 4. That's 2 pi. Let's put a 1 here. Let's put a negative 1 here. And we know that cosines always start up top at 1. But that's a cosine graph. That's a regular cosine graph. Can we simplify this? I mean, with cosine, it should be pretty easy enough to simplify. So let's use the formula for cosine when we add two variables together. That's going to be cosine of alpha, which is the cosine of 7 pi over 6. Well, the cosine of 7 pi over 6 is negative square root of 3 over 2. The cosine of beta is just cosine x. All right, sine of alpha is negative 1/2, and the sine of beta is sine of x. Then we use the sum, so cosine of alpha, which is negative square root of 3 over 2, times the cosine of beta, which is cosine x. That's going to be minus the sine of alpha, which is minus 1/2, times sine x. Well, that's just going to be the square root of 3 over 2 cosine x plus 1/2 sine x. So we go ahead and do this. So if I were to put in 0, this is just going to be the value of cosine 7 pi over 6, which is negative square root of 3 over 2. I can put that into a calculator. And that's going to be 0.866 when x is 0. So 0.866 is basically right about here. Now here's the nice fun thing. Let's just do this quickly. This one down here, let's do that one quickly. If x is 0, it's the same idea. It is, what was it again? The square root 7 pi over 6 is negative square root of 3 over 2. So if x is 0, the cosine of 0, or comes cosine of, cosine of 0. I'm sorry, cosine of 0, so that is my angle. Cosine of 0 is 1, so that's going to be negative square root of 3 over 2. And the sine of 0 is 0, so I don't need to worry about that. So that is negative square root of 3 over 2. That is exactly what I just plugged in here. Actually, it was negative. I was supposed to move it down, move this to the bottom. It's negative. How do I know it's negative? Because negative square root of 3, because cosine, 7 pi over 6 cosine, and I can bring it over here. 7 pi over 6, its cosine is negative square root of 3 over 2. So I should have written, or I should have drawn that dot down here. I'm going to do that again. There we go. Okay, let's put in pi over 2 for x, and let's see where that is. So pi over 2. So we're going to have to do some addition here. 7 pi over 6 plus pi over 2, if I can do that. And if I were to multiply this by 3, I would get 10 pi over 6. If I divided, that could work. Oh, no, I actually can't. There is no 10 pi over 6 on that, on the circle. But what if I divided by 2? That's going to be 5 pi over 3. Is there a 5 pi over 3? There is. So I can look things up here as 5 pi over 3, cosine of 5 pi over 3. And the cosine of 5 pi over 3 is 1/2. So I should be right here. I can do the same thing down here. The cosine of pi over 2, or sorry, cosine of pi over 4 is the square root of 2 over 2. So let's multiply square root of 3 over 2 times the square root of 2 over 2. And pi over 4, and that's pi over 2. Yes, that's pi over 4, that's pi over 2, that's 3 pi over 4. Boy, see, this is how I have to keep correcting myself. So right, this is pi over 2. So I do need to make that distinction. The cosine of pi over 2 is 0. So this will actually cancel out. And I'm going to be adding 1/2 sine of pi over 2, which is 1, which is 1/2. And so again, I have matched that. Cosine of pi, if I take 7 pi divided by 6 and I add pi to that, so let's do a little, erase a few things here. So 7 pi over 6, and I were to add pi to that, that's just going to be 6 pi over 6. That's going to be 13 pi over 6. And I can use a reference angle, because I do know that this is the reference angle to this one is pi over 6. I do know that, because that's 2 pi with a pi over 6 remaining. So I can find the cosine of pi over 6, which is the square root of 3 over 2. So the square root of 3 over 2 is, what was that again? Something, is it right about here? It's pretty close to where 1 is, so it's probably going to be right about here. Okay. And then we need to find the same one for this one. If I use the cosine of pi, I get -1, so that's going to be square root of 3 over 2. And if I use sine of pi, I get 0, so square root of 3 over 2. So this point is also the same. So I think with that, I've discovered that these points are going to be equal to each other. So let's just go ahead and finish this off, except this time I'm just going to use this part down here because I find it easier than just adding things up here. So cosine of 3 pi over 2 is going to be equal to 0. And the sine of 3 pi over 2 is -1, so that's -1/2. So we are now down to here. And then 2 pi should be exactly the same as what we had here because it's a cosine. And things really look weird when it comes to this cosine graph because it just looks off. It really looks off. But we have determined that this and this are indeed the same. So we can double check. Cosine of 0 is 1. So that's the negative square root of 3 over 2. Plus 0. Negative square root of 3 over 2 is negative, so we start here. The problem is I got to figure out where my midline is. I'm not quite too sure. Well, I'm starting here, right? So if I'm starting here, I must have pushed my graph over. So when are things equal to 1? That would be an interesting thing for me to discover. When are things equal to 1? Because obviously this graph is going to go up to 1 at some point and then come back down. And I have a feeling that it's doing something similar to this. You see what I mean? I feel like it's coming up here, reaching a point up here, and then coming back down again, and then through the midline to reach this point here, reaching another point here at its bottom, -1, to come back up again and reach 2 pi at this point. That's my interpretation of that graph. It's the only interpretation that really makes sense at this point. So again, you can see how I'm kind of going through this homework assignment, trying things here, trying things there, and realizing that over time that these two are in fact the same. And what I just end up doing is I will maybe start here with graphing, verify that the same angle x is going to give me the same exact value if I were to plug it in here, and keep going until I have what looks like a graph, and then from there try to draw to the best of my ability, to the best of my interpretation, what that graph is. All right. I think this is the last problem, and this problem, what they're trying to do is they're trying to ask you, if I can find what this problem is. I'm trying to see where this problem is. This could be from another homework assignment that I just have. Oh, no, this is problem number 18. Okay, I just have this mislabeled, so you were probably wondering why I skipped 18. Sorry. So following exercise to simplify the given expression. We are to simplify this. So go back to 18, and what does this look like? Well, doesn't look like a cosine difference of sums, but it could be a sine difference of sums, and sine alpha, cosine beta, cosine alpha, and sine beta. So here we go. We need to do the following. 2x could be my alpha, and 5x could be my beta. So if I were to write this out as sine alpha cosine beta minus sine beta cosine alpha, does that match anything? Sine alpha cosine beta minus cosine alpha sine beta is equal to sine alpha minus beta. That is the formula. That is the identity. Well, if that's the case, then I have sine 2x minus 5x, using this information that I wrote up here and applying it to this, which means that my final answer here is the sine of minus 3x. Just using the same identities, but in reverse. All right. It did take me about 50 minutes to do this homework assignment, but we'll have a couple of days to do it. At this point, you should be ready to take the quiz on Friday, and I'll have some delta math for you guys to practice as well. What's going to be on the quiz? These identities, 100%, will be on the quiz. I'm most certainly going to ask you to give me an exact answer for these. Let's see. I don't think I'm going to have you simplify that one. What I might do is I might have you use cofunctions to determine whether or not something is equal in that sense. What I might actually do, because that cofunctions work with this sort of thing, I might actually ask you to do one of these problems and graph it and prove to me by simplification that this simplified will produce the same graph. And I'll have a rubric that will allow you to tell me that should let you know that you have in fact proven it to me. And I would imagine that the rubric would be, you need to prove to me that when x is inserted into this formula here, when x is 0 or pi over 2 or pi or 3 pi over 2 or whatever, that when you have given me its simplification, when you have written out its formula or you've simplified it to this, that this value, 0, pi over 2, pi, does in fact match that. And so you would graph them both, and you would show that that's exactly how that works. So that should be all for the quiz. If I have any other information for the quiz, I will put it into my BC, and I should be back on Monday. So good luck with this. This is okay. It's good high-level theory stuff. Takes a lot of practice. So we should be good going into Friday. Have confidence. You guys should be good going into Friday.